Now we're going to look at the outcome of faults. At the end of this part of the session, you should all be able to list some potential causes of fire in an electrical system, explain what might cause a system to keep tripping, and list some causes of electric shock in a domestic electricity system. So, worth noting, before we're qualified, unless we're competent, we shouldn't work on electrics. If we suspect a fault, either inform your supervisor if you're working as a plumber, or get a qualified electrician in to check it. If there was a major fault that you were competent to recognise, what you would do is you'd inform the customer that you need to isolate that appliance, cut off the supply to that appliance so it doesn't pose a danger to them. So there's a few things that could lead to fires in electricity systems. One is an oversized circuit breaker. If the circuit breaker is bigger than the size that the circuit can take, then too much current could flow into the circuit potentially, could cause the wires to heat up and potentially lead to a fire. Also, if the wires aren't big enough, if you don't use the correct size wire for the circuit, potentially you could have the right size circuit breaker normally for a circuit of that type, but the wires, if they're not big enough, could then heat up and then potentially catch fire. Another thing that could cause a fire could be a loose connection. If you have an increased resistance, which would happen if you had a loose connection, that often causes things to heat up and potentially could then lead to fire. So next we're going to look at electric shock. So damaged insulation can lead to electric shock. It can also lead to a short circuit as well, because it could allow the live into the other wires, directly into the other wires. So if we've got damaged cable, there's a risk of electric shock. If we've got damaged junction boxes, for example, again, there's also a risk of electric shock. Okay. Another potential cause of electric shock could be the removal of protective bonding, and by that I mean taking off earth wires, either disconnecting the main equipotential bonding or disconnecting supplementary bonding, which would sort of go over a plastic fitting or whatever, for example. And that would mean that potentially there could be a live connection connected to a pipework. If a live wire did come in contact with a pipework and we didn't have the protective bonding in place, we could then be electrocuted when we touch that pipework. Okay, tripping out. So basically, if there's more load going into a circuit than the circuit breaker is designed to take, then it will trip out. This would normally happen if there's too many appliances connected to a circuit. If there's too many appliances connected to a circuit, it will draw more than the design load and it'll trip the breaker. It's also worth noting if the circuit breaker is undersized, the circuit will also keep tripping out, because there'll be more than the design load passing through it. Now it is time for your task.